Hey, what's up, guys? This is Brett Hall, and today I want to talk to you a little bit about 802.1x authentication. And so, what I'm seeing is a lot of organizations mandating that the network team enforce 802.1x authentication. If you're not familiar with that, and you have more of a UC background than a network background, essentially what it is port-based authentication that is stronger than traditional ways of allowing endpoints onto the network, like port security or MAC authentication bypass. It uses some kind of username password combination, uh, typically using a database. And typically, this is referring to users that have PCs and they're authenticating on the network. But but because organizations and enterprises are pushing this out across the board, I wanted to talk to you because there's a lot of UC endpoints on these networks, and you have a choice. Do you want to do full 802.1x authentication for these UC endpoints, or is it better to do things like authentication bypass, which is a option if you have a server like Identity Services Engine that Cisco provides. Traditionally, most organizations probably either do port security or MAC authentication bypass. But if you know anything about the network, you'll know that these two methods are based on the MAC address of the endpoint, which can be easily spoofed. And so when I talk to people, I typically recommend digging in a little bit and doing the best authentication method, which is 802.1x. So there's some benefits that you would get if you do this method. The first method is obviously the strong authentication, but also you always have a good understanding for what kind of endpoints are connected to the network and how they're connected to the network. Besides just looking at your call manager phone control page or GUI. Also, if you ever wanted to do some kind of incident response, maybe you have something that you've detected in the network that's bad. You have the ability to leverage ICE and remove that endpoint from the network, or leverage the Identity Services Engine to do things like investigations or forensics, digging into logs, things of that nature. So just a quick little overview of 802.1x. So the basic components involve the switch, the access layer switch that your endpoint plugs into. Hopefully it has PoE, but that's not a requirement for .1x. Then you have an authentication server such as Cisco Identity Services Engine. There are certainly others out there that can do 802.1x authentication. I won't go through any of the names, but I have run into some of the names, some of the third-party products when it comes down to endpoints, and I think most of it is because of the long string that's used with authenticating a IP phone, for example, versus a traditional username and password combination. So we're going to focus on ICE today. Then you also have the authentication database. Now, ICE has its own authentication database that's internal, but when you're authenticating users, typically you can use things like Active Directory as a database to authenticate to, and maybe I'll show you what that looks like today from an ICE integration perspective. Then we have the supplicant. This is actually what resides on the endpoint that provides the credentials to your authenticator switch, and the authenticator switch basically just relays as those combinations, those username password combinations, your credentials to ICE, and ICE tells the switch whether or not to authenticate the user onto the network and then what kind of authorization the switch should provide to that end user. That's why Identity Service Engine or any kind of radius server that's used for this is typically referred to as a AAA server, providing authentication, authorization, and accounting. Last but not least, you have your PKI, and your PKI is just based on the certificates that are used for authenticating, and within ICE, how to trust those certificates to ensure a successful or unsuccessful authentication to the network. What this looks like from an architectural perspective is you have a bunch of endpoints, whether it's a UC endpoint or a PC running a soft client like WebEx or Jabber. They have your switches, and again, these are sending the information over EAP. We're going to use TLS to secure this EAP connection within our architecture. The switches essentially, like I said, relay this information over to ICE using this radius protocol. I forget what radius stands for, but I think it's like traditionally used for dial-up scenarios, but it stands for remote authentication something. That's radius. And then as you can see here, ICE has its own kind of internal database, but it also can tap into Active Directory. But we know we're not going to use Active Directory for authenticating a phone. We can use the internal database and the trusted certificate store within ICE's internal database to authenticate an endpoint. And you may not know this, but when a phone ships from Cisco, you have a native supplicant built into the phone, and typically you have a certificate that is installed at the manufacturing process. That's called the MIC, Manufacturing Installed Certificate. We can use that, and we'll show that today. But then in the future, if you want to push out your own certificate that has been generated by CAPF, you can deploy what's called a locally significant certificate, which is a stronger level of security, because that certificate would be unique to your own enterprise and your own local area network. So it'd be harder to spoof. It'd be harder to masquerade. So you have truly trusted TLS connections when you push out your LSCs. And like I said, we take these certificates from Call Manager and we export them into ICE, and ICE is able to trust these certs and use them for authentication purposes. So that's a high level of the architecture, and if you were not a savvy UC or network admin, you probably wouldn't be listening to this video. But of course, we need to have somebody that understands a little bit about the UC environment, and then is savvy enough to work with the people on the network side to get some of this configuration up and running. Sometimes with small customers, people do both the network and the UC stuff, but oftentimes it's working across teams and getting along and convincing someone to do something. From a configuration perspective, there is configuration in Communications Manager, mainly just to take the certificates out of the certificate store within Communications Manager, and I'll show you that. But then also just to enable the phone for .1x authentication. Most of the configuration is done on ICE and the switch. For today, I'm just going to walk through ICE because when you start talking about the access switch, there's so many different variables at play depending on the version of code that you're running, iOS or iOS XE, and then depending on the version of code you're running, you have different kinds of ways to configure the policy. Cisco calls it IBNS version 1, and then the new model is IBNS version 2. And so there's so much variation here. If you really need something, I could probably show you what my configuration looks like on my switch to get things working. But for the most part, we'll spend some time going through ICE. So that's it for the quick little intro. What I'm going to do is pop over to my web GUI, and I will show you the Cisco Unified Operating System Administrator page. Of course, this is where you get your certificates from under Security and Certificate Management. And we're going to look for the certs that start with Call Manager. Since we're using the MIC, this will be pretty self-explanatory. But within your certificate management page, you'll see these descriptions here and which certificates were used to sign the certificate that was installed on the endpoint at manufacturing, also known as the MIC. So essentially what you'll do is everything that has a description that is relevant for the MIC, like this manufacturing CA certificate, this one, this high assurance SUDI CA certificate, all of these you'll want to click on, and then you'll essentially export this to like your desktop or somewhere on your PC. This is in a .pem format. I've already downloaded it, so I'm not going to do that for today. But you'll download all of those, and you'll take that, and at some point in the future, you'll upload into ICE. So I'll show you how to do that today. So we pop over to ICE. Well, I think most of this is pretty self-explanatory, but the other thing that is done before I forget is enabling 802.1x for the phone. Now, I think you can do this with using the bulk administrator tool, but for test purposes, I typically recommend organizations to do this like a handful of phones at a time. And so what you can do is go on other phones, and I just have a small lab environment here. Oops, clicked on the wrong one. Go on your phone, and then you search for 802.1x authentication. And you can see here, you just want to enable this this drop down here, and make sure that probably changes. Once you hit save, you'll want to apply the configuration, and then your phone should be set for .1x. So the next series of configuration tasks is on ICE. And before I get into that, if you're not familiar with ICE, I figured I would just orient you a little bit towards what kind of visibility and control that you might get if you do .1x authentication with ICE. So you see your authentications. I'm not quite sure why it's not showing that, but my phones are certainly authenticated to the network, and I'll show you that with my switch. The command is show access session, and you can see it's authenticated using 802.1x or .1x, and the MAC address associated with the endpoint there as well. So that's how it's authenticated. If you want to see some more details around this, I think it's access session MAC. I'll just copy this in there, and then detail. So you see the different phone model, and like I said, it's got a long username. It's got the CP, the model number, followed by SEP, followed by the MAC address. So that's actually the username. Within a switch port, you have different things that you can configure, like multi-domain mode or multi-domain authentication, which is really useful if you have a PC plugged into the back of your phone, like a lot of customers do. And then you also have policy as well, right? So I have actually a permit policy. I have an ACL that's configured within ICE that's pushed down to my switch port, and it can control what kind of resources my phone actually has access to. So that's kind of what the config or the verification looks like on my switch. And then now going into like network devices, I'll show you how these phones have authenticated and what kind of attributes you can see from ICE. And so just real quick, you can see the username matches what I showed you earlier from the switch. I'm going to click on the MAC address, and then you have attributes. And there's nothing really here under general or custom. What we're going to look at is other attributes. And you can see this is my authentication policy. Actually, this is my authorization policy, which all makes sense here in a minute. When I start moving to that page, that policy set page within ICE, this is the IP address of my ICE. This is my authenticator, which is my switch, an IP address of my switch. You see some certificate information here. You see the model number. This is my host name of my switch. You can see we're actually using TLS version 1.2, which is currently the strongest mechanism for security using TLS. And you see interesting things that are typically associated with things like network access control, or NAC, like total certainty factor, and how certain ICE is about the device coming onto the network. In this case, it says, hey, I'm pretty sure, I'm 96% sure that what's coming on the network is an 8841 phone. Its operating system looks like an 8841 phone, and so that's probably what it is. What's funny is you can see username is actually an 8865. If you go back to call manager for a second, this is an 8865. So that 4% really makes a pretty big deal. Looks like I need to go in there and tweak how it identifies the operating system, but maybe that'll be saved for a different day. So these are the kind of visibility things you can get from within ICE. I'll close that out. Then you also have what's called live logs, and if I would to reset the port, you would see this. I think it archives it. Because this has been authenticated now for longer than a day. Not quite sure why that's not showing up. But you would see authentications here. Let's go back to configuration for a second. And I think the first thing that I mentioned that we want to do is take a look at the phone certificate profile. So what's cool about ICE, they've really done they've done a good job with ICE 3.1, which is the newest release that came out, I think, about a month ago. And you have the ability to look for to do a search for things. If I could spell it right. I think it's under identity. The identity. External identity sources. Yeah. Certificate authentication. Okay, I was saying it wrong. So you have a preloaded certificate profile, which we can look at. The certificate profile is basically specifying use of the subject common name. All I did was kind of recreate that for the phone just to give it something meaningful for when we create our policy. But that is the attribute you'll be looking at within the certificate, the common name. you also have your Active Directory, like I was talking about earlier, which is what you would use if you ever wanted to authenticate a user through AD. After you have your authentication profile set up, then you have something called a source sequence, and I have one for my domain, but I've also created another source sequence that's unique for my phone. Because like I said, we're not going to be able to look into Active Directory for the phone. All I want to use for authenticating the phone is the internal database. So I simply just moved the internal endpoint thing over. You can just use this button here. I moved it over, hit save, and I've referenced my phone certificate profile here. So after these two things are done, really you're going over to the policy set. And this is really where the magic happens for getting a successful authentication to the network. So a default policy is all we can use, or all we need to use. And like I said earlier, ICE provides authentication and authorization. But for the moment, we're just going to focus in on authentication. And there's some stuff in here by default, but this is where we enforce the security policy. And so typically, you're going to want to have things like .1x first, almost like an access list. You're going to want to have your preferred method of searching how you should authenticate your devices. And then slowly, you have the ability of either continuing the process, right? Or you could certainly say, hey, if he fails authentication here, just reject the authentication request. But the way I've set it up is I can continue and allow users to authenticate through .1x, and whether it's wired or wireless, there's not really anything different, but you may want to have a different policy for how you authenticate users and how you allow them on the network, especially if you have like guest users or corporate users, things of that nature. And then we didn't really talk about this earlier, but typically organizations have devices that simply don't have a supplicant that is capable of doing 802.1x. This is why the mac-authentication bypass rule was created, or capability was created, to allow things like printers, IoT devices onto the network. But where that is important, right? And you can see I'm only looking at internal endpoints for my MAB policy. Is you ought to think about how you want to authorize them on the network. Is there a way of segmenting these kinds of devices off from the rest of the network so that this is not a threat vector or attack surface that someone can exploit? If you know anything about security, your security is typically only as strong as your weakest link. And if someone really wanted to get in, they'd be looking at those dumb printers or IoT devices to try to get in. And so that's why you want to have your segmentation in place. So I've configured wired .1x for the phones and using EAP-TLS. The way to create this policy is pretty straightforward. You simply just click on it, and then you have a editor, and I just basically drag and drop some of these things like wired 802.1x into this editor, along with the EAP-TLS portion. And then along the way, you can say, hey, I want this to be an and condition. I want the endpoint to be plugged into a port like gig 1010, like my phone was plugged into. And I want to specify that we use TLS-based EAP when we communicate with the switch. So that's that. And then in order to enable that, you would hit use. Obviously, I've already done that, so I'm not going to do that here today. But pretty straightforward. Phones can do TLS because we're using certificates. We're using either the MIC or the LSC. For Windows clients, the native supplicant does what's called EAP MS-Chat v2. Now, I don't know all the details about EAP MS-Chat v2, but typically a user would get a dialog prompt pop up, and you would type in your username and password, and you would authenticate that way. There's no certificates involved. The exceptions could be, if you have a smart card reader or something that you actually have a card plugged into, then you can be using certs, but that's kind of beyond scope of our discussion here today. The second piece of AAA was authorization. And again, we have the ability to just use this plus button, and we can add a new authorization rule. I've already done that here, so I'm going to go ahead and delete that. But the way I've done it is to try to depict some of that segmentation piece I was talking about earlier. I would have more trust for endpoints coming on the network that have a locally significant certificate, because I knew that I issued that certificate than an endpoint that just happened to be coming on the network using the MIC for authentication. So that's why the LSC is listed first. And you can see here, I haven't done any kind of authorizations for LSC yet, just because I'm starting off with a MIC. But at some point, I will go into Communications Manager, and I will configure it to push out my certificates using CAPF to the phones, and I'll start to see hits here. For the moment, I'm using the MIC, and you can see I have hits here under this authorization rule. And if you see the rule, it's pretty straightforward, right? The issuer of the certificate is Cisco, and so all we have is a rule here that says, hey, if the certificate issue contains Cisco, that's the MIC, and that's how to identify which rule set we hit. This is my authorization profile. You can see here, I created that earlier. And then if you want to do some more segmentation, you could have a certain security group tag, maybe like a contractor or a BYOD here. But again, that's probably out of scope for our discussion today, and we can discuss that a little bit later. Typically, that refers to what Cisco calls is TrustSec, where there's a separate tag associated with a certain security group, and that allows you to have certain access to resources. So that's the policy set and authorization piece. I think the next piece is to import the trusted certificates. So I'll show you that. And that is under Administration and System. And so if I had my certificates, I would simply just click on Import here and import the certificates. Now, by default, you'll see here on the right, they actually come in disabled by default. So once you import your certificates, like your manufacturing CA, or I think in the example I gave you, what CA did I use? I don't see it. Oh, it was this one, manufacturing CA3. I exported that earlier. It'll come in by default disabled. So I think, how do you do this? Oh, yeah. If you want to enable it, you can simply click on the certificate, hit edit, and then the drop down for enable. So that's that. Pretty straightforward. And this is, like I said, what you use to create that trust, as the phone provides certificate to the switch. Switch provides that certificate over radius to ICE. And ICE says, oh yeah, I trust that certificate. In fact, I signed it. Of course I trust it. Allow this device onto the network. This is very straightforward. The last piece is adding your network devices. And that is here. So you have your network devices. These are all the switches you know about in your network. I suppose if you wanted to, you could do some wildcards. I have a small network, so I just did a /32 mask of my two switches. You have that, and this is where you configure your name. Cat 9200 is the model of my switch. But then really, you choose your radius authentication and then a shared secret within your switch config. And so that's how you know that a connection between your switch and ICE is authenticated. And you do that for all your network devices. You may be able to get away with just having a default device with a shared secret of radius in your switch. So going back to my switch config, this is what mine looks like, right? Mine looks like I'm running, I think, 17.3 code on my switch, but it's like AAA new model, and then I have my radius server with, this is actually my IP of my ICE server, the port, and then my key. And my key 23AZY would be what matches here, my shared secret. So after you do all that, you have pretty much everything ready to go. Now, obviously, there's a lot of configuration here, and you'll want to work with the network team to figure out what this should look like. And you can see, because there is so much configuration here, hopefully standardization is not a problem for you and your organization. But you'll want to standardize on a good .1x config. Especially, prior to rolling this out to production. Otherwise, you could have some unexpected issues occur. So this is kind of like the global configuration of my switch, and then I have my individual configuration on my port. So here's where I attach the .1x policy, and by the way, I'm using Cisco's IBNS 2.0 framework. But I have configured things for like .1x and how often to re-authenticate my endpoint. And I have port control, periodic. This stuff is extra device tracking attached policy. I think it's just for tracking what kind of stuff's on the network. I'm not quite sure. It was a best practice I followed, but this should work. One of the things that I hear concerns about is around a problem or a challenge with doing .1x authentication for phones. Is that what if the ICE server becomes unreachable? We can't have a user try to call things like 911 or somewhere else, and that phone not be allowed on the network, right? So Cisco has something called a critical voice VLAN. And again, this might differ from version to version on your switches, but that accounts for this, right? So my ICE was down for a long time just for maintenance purposes, but I was allowing my phones to get on the network because of this critical voice VLAN feature. And you can see how that's configured. Pretty straightforward with interface, a voice VLAN, and the VLAN number. So hopefully that helps you understand a little bit more about 802.1x authentication and how you would go about starting getting this working in your organization for all of your UC endpoints. Hope you liked this video. If you did, give me a thumbs up, and check out subscribe for all my future videos. If there's something else you want to see, like how to go into some of the further capabilities of ICE and NAC and things of that nature, please drop me a note, and we'll take it into consideration for future video. Appreciate it all. Have a great day.